Welcome everyone. Welcome to this webinar on Stratasys AM solutions for intelligent mobility. So here we are going to talk about how the Stratasys solutions, 3D printing solutions are being utilized and what are the benefits, what are the areas that we have been able to provide a good materials and the good machines and good work process workflow for the intelligent mobility solutions in whether it's for the automotive market, for the rail transportation, or for the aerospace industry. So let's jump into it. So before that, let us introduce ourselves. We are Altem Technologies. We are a 3D innovation platform company, and we have the solutions for a complete product lifecycle management. Like for design, we provide the solutions for Dassault systems, for CATIA, Delmia, 3D Experience platform. For simulations, we are associated with Hexagon MSC software for Nestor and Adams, computational fluid dynamics, and manufacturing simulation. For 3D printing in India, we are associated with Stratasys. Stratasys has been an inventor of ADM technology, and we have many more technologies like PolyJet, SLA, and Potter-based technology. Then on the 3D scanner side, we are associated with Artec 3D, which is a Luxembourg-based company, and also it's a wireless 3D scanner. Then for the materials and for the new drug discovery simulations and its product development, we have solutions from BioVia, which is from Dassault Systems again. And for 3D bioprinting, we are associated with CellLink Life Sciences. So we have been into the market since last 10 years, since 2011. And we have been able to bag many prestigious awards like from MSME, from Stratasys itself, from Frost and Sullivan as a most innovative 3D printing company of India. So let me just give you a brief about the Stratasys and the FDM technology here. So FDM, which is fused immersion modeling, was invented by Mr. S. Crott-Crum, who is also the founder of Stratasys in 1988. And since 1992, they have been going commercialized with their first 3D printer sold, which was called 3D Modeler. And as you can see on the screen, that the old models of Stratasys and now the new models of Stratasys. So Stratasys comes with the 30 years of experience of additive manufacturing worldwide and in India also. And since then, there has been a lot of development, lot of more than 1 lakh plus installations, and the company itself has 1400 plus patents, and they have 31 global offices, including in India. So why Stratasys FDM has been most trustable, reliable, and accurate machine in the in 3D printing industry because of its unique repeatability and process control. So they have worked out a lot. They have understood the what are the challenges that have come out across the year with the FDM technology when we are printing very high engineering materials, and what are the failures, what are the causes which what are the points which causes these failures. So like for the debris from the tips where the burnt material used to be there for the after the 3D printing, then the moisture uh, which gets attached to the materials, which also causes the part failures. Then they have developed a new tip here, which is called T16, and since then they have tested out, and they have noticed that there has been some risk reducing features. They have introduced it, so they can do the temper resistant files, which are the locked CMB files for 3D printing. They have introduced the moisture management and the monitoring system, which can monitor the dew point, and it that dews can be removed from the material chambers by the powerful airflow dryers. They have also developed a best-in-class operational systems, and also for production monitoring, they have included the internal camera so that you can remotely monitor what how your product is building up in the machine. And also with the third-party mechanical readability studies, so the machines were tested by many of the third party customers or third party reviewers, and we have noticed that the FDM technology has provided more mechanical properties, geometric dimensions, uh, as a front runner for manufacturer readiness. So if we talk about the industrial applications here that can be done using the FDM technology, using the Stratasys solutions, those are with the large part for the prototyping purposes. So we can make the complete fenders, bumpers, front grills, back grills, complete dashboards also in a single print go. We can also do the functional prototypes for the functional validations and the functional testings before you go into your final manufacturing, or can be used as end use part. Then for the models, for the marketing, for the commercial support, where you require the samples, where you require the showpieces, or where you require a final object in a scaled down version. So that can also be done for the manufacturing floor. On the shop floor, we can do for the jigs, fixtures, and tools. We can make the patterns for sand casting. We can make the fixtures for the CNCs, greasing jigs. We can also do the production line automation by including the 3D printed jigs and fixtures. We can also make the protective parts in nylon carbon fiber, which is a stronger material, lighter one, with the outer covering in elastomer, with the thermoplastic polyurethane at the 92A Sure hardness. We can also do the low and high temperature masking set 213 degrees Celsius. We can also do the low and high temperature masking set 213 degrees Celsius. We can also do the composite tooling. We can make the large gauges also, large size gauges. For the production side, we can also do the end use part, which can be used with the replacement of the metal parts by using a stronger nylon 12 carbon fiber material. We can also make the spare parts which you require in a batch production. We can also do the production of the parts where you require the customization, which has a volume less than 1000. That becomes very cost effective. So what are the proven applications that we have in the mobility? So if we talk about nowadays, now the e-vehicles has been growing up into the Indian market and globally. So for the e-mobility, how you can incorporate this technology in your work process flow for prototyping, or for the jigs and fixtures, or even for the as a final use part. So this is one example here for the battery housing, where the prototype was 85% using the Stratasys larger format F900 3D printer, and the material that has been used here is the nylon 6 material, which is again a high performance thermoplastic material. The functional parts were able to sustain the weight of a person. So we can in a faster manner we can test it out uh, all the battery housing capability in the e-vehicle system, or we can also do the faster prototyping in for any product, for any part, any component that can be included in a e-vehicle. This is one more example for again a solar powered e-scooter here. So the prototyping was 50% faster, and here they have used UV stable ASA material. The functional parts were again able to sustain the weight of the person, and the lead time reduction that has been noted about 50% for their prototyping and design and development. This is again one more example from Rinspeed company. It's a new autonomous mobility company. For the new mobility companies, it can be used for its final product also, and with the aesthetic parts also. So they have printed about 30 interior and exterior parts to make their concept car with the Stratasys Photos production series machine 450 MC. They have used the UV stable ASA material and nanometer carbon fiber, which provides a high stiffness to weight ratio and very good structural strength to make your heavy sustainable, and for the replacement of metal materials. This is one more example for the aviation, for the electric aircrafts. For the company, Aviation 3D printed its wing tip motors within 20 hours. So you can see the part in the photo, the 3D printed one and the conventional part. The 3D printed composite layup tool, for its composite layup tooling, we have used Ultim 1010 material to manufacture the carbon fiber parts. And as per their data, in their 2 years of operation, they have saved thousands of dollars of uh, of their cost in the product development of this electric aircraft. And within the six, and they have also saved 6 months of workforce hours uh, by including the 3D printed machine in house, so that their engineers can do the faster prototyping with the in house facility. This is one more example for a supersonic mobility company called Boom, who makes the supersonic supersonic aircraft. So you can see there is setup on your screen that they have a large form. They have from a desktop one to the large format machine here by the Stratasys, and you can see how they have utilized, how they have make their 3D printed parts completely for their shop floor. So they have made hundreds of jigs, fixtures, and tools, and also the find and use final flying parts also. So how opportunities can come up with the auto manufacturing in automotive. So we in the automotive we can make the large part sizes with our large build platform. So we can print about 1.4 meter of the part of a single in a single print. So this is a front grill printed in our larger format F900 in within less than 24 hours, which if you go for the outsourcing, if you go for the conventional method, it will take several weeks or months of time just to develop one model. But here we have done in just about 24 hours. So we can reduce the turnaround time by 50% compared to the traditional methods, and we can accelerate our time to market, which has a huge cost impact on your final product. Then how FDM can be used for the tooling because of three reasons, which is the impact, strength, and heat resistivity. So with the impact resistance, we have the materials like the nylon. For the best mechanical properties, we have nylon to carbon fiber. It's easy to use. The 3D printed part is easy to use because it will be lighter weight as compared to your metal parts, and there will be no powder or resin spill on the factory floor, on the shop floor at this spot. We have the certified material which can be used in the aerospace, rail, bus, or in the for the medical devices. One printer can covers multiple applications, like you can make the greasing or seal assemblies, composite tooling, uh, thermoforming tools, sheet metal forming tools, aluminum steel tool lightweightings. You can do the electrostatic dissipative properties. You have the biocompatible material properties also. So all these things can be done within a single printer here. So this is one example from General Motors, from Chevrolet. You can see on the screen that how they have utilized this machine. They have created this fixture here. Uh, this fixture here. So this is a rear wheelhouse hemming tool, which is used to join the sheet metal fender panels. Okay, the aluminum tool is replaced from the 3D printed ASA material, which is equivalent to the ABS mechanical properties that, and also it saved the potential for damaging the sheet metal. The weight reduction of the 34 kg of metal tool was reduced to more than half, up to 14 kg of the final 3D printed tool. So the weight reduction was about 56%. The time of this manufacturing was savings what about 70 to 77%, and the cost was lowered down by 74% for the developing of this tool. Then for the automotive gauges, we can also do the large parts on our larger format machine. So the heavy metal gauges can be replaced with the lightweight ABS part. Jigs and fixture costs can be reduced over 50%, and tool production time can also be reduced by 40 to 60%. This is one more example for the automotive assembly tools here. So Eckhart, they are specialized in the tooling, in the tool manufacturing. So they provide the customized tool as for their customers, as per their application, as per their requirement. So you can see the multiple examples here on the screen here. The screen wrapper assembly tool, which is 1 meter, and that has been printed with nylon carbon fiber. Then we have the assembly tool also for the leaf spring also. So here you can see that these tools do not deform like the aluminum tools, which was a challenge. Uh, and also this brake pedal assembly tool, the weight was just about 230 grams. Okay, which was a very over 1 kg or 2 kgs for the aluminum tool also. The leaf spring assembly was made in 12 nylon 12 carbon fiber, which is 3 times lighter than the metal tool. This is one more example from the GK and driveline. For the automotive driveline, for the greasing jigs, we can use our Ultim 9085 material, which is chemical resistant for the grease material. So you can replace your metal fixtures here, and you can use this thermoplastic Ultim 9085. So that can help to reduce your lead time. The complex assemblies can be produced in a fraction of the time. You can also make the end of arm tools where you require the contact for the any chemical or the grease. You can make the clamping tools for automation in Ultim 9085. You will get the highest stiffness, and you can replace some metal clamps there. We can also do the automation line. On the automation line, we can also do the lightweight jigs. We can replace our heavy So in this example, you can see that the heavy metal jig, which was weighing around 68 kg, were just reduced to 12 kg of the weight by using our Ultim 9085 metal, which is lighter, stronger, and more durable part. So the turnaround time was 16 to 20 weeks, was just reduced down to 3 to 5 weeks. The ROI by the Solexis was just achieved within 12 months, and there has been a lot of savings in their labor time also. Even by the Siemens, who works on the automation and robotics. So the Siemens AG, they also use it. They make the 3D printed robot grippers with the ABS ESD7 material. ESD is the electrostatic distributed material which is used for electronic assemblies. So they make the assembly jigs, product trays, grippers. They do the rapid automation solutions by using the 3D printed trays, brackets, grippers, and stops on the aluminum frames. For the mass transportation, here we are talking about the stocks, or we can say the railways. So for the railways are materials. Uh, uh, so the category here which is required here for the fire safety for railways. So there are three levels of the hazard level classification: HL1, HL2, and HL3. So for the HL3 fulfills HL2 and HL1 requirements. So for this fire safety by the railways, we have the material Alter 9085 again, and our pack based material, which is Antero 800 NA. They have been able to pass both of these metals have been able to pass the category test of EN 455452 on all hazard levels of HL1, 2, and 3 by fully demonstrating that they're suitable for use in production for the rolling stock industry. So you can see the example here of here Antero part, this Antero material, and the part in action here is the air duct. Okay, due to its fuel resistance and lighter weight. And the second one is the Alten 9085 resin environmental control duct. Now, if we talk about the railways, that how we choose the FDM material for the railway components, okay, for the interior parts which weighs less than 100 grams, okay, the exterior parts which weighs less than 400 grams, okay, and the interior parts which weighs more than 100 grams, or exterior parts which weighs more than 400 grams. So we have the all FDM materials for less than 100 and 400 grams, and we have the certified FDM materials which require more strength, which requires more weight density to handle, which weighs more than 100 and 400 grams. So we have the certified FDM materials for that Antero and the Ultim material. So the interior cabins in the railways, we can make the parts using Ultim 9085, like the cable clips, connector brackets. We can also make the air ducts for the HVAC systems, which requires the FST certifications, fire, smoke, and toxicity. For that, handles, or for the safety devices which are installed for the passenger safeties, like so we can use Ultim 9085, and we can wrap around the glass fiber sheet, or we can do the carbon tooling also, carbon fiber tooling also here. For the TV screen housings, again we can use the 9085 material. For plugs, electric cable holder, individual tables, seat armrest. So all these interior components of railways of the stocks can be 3D printed by using an Ultim 9085 certified material. For the exterior, then we can use multiple materials here. Like for the louting or for the sensor housing, we can use the ASN alternate carbon fiber. For large covers, we can use the Ultim 9085 or nanometer carbon fiber. For air vent systems, information display housing, headlamp housing, front bumpers. So these are some of the exterior parts which we can 3D print for the rolling stocks. This is one example here by the for the by the Angel Trains and ESG Rail. So this is the first 3D printed parts that has been installed on a British passenger trains, and the materials cost saving was about 50%. There is a lot of lead time savings also. So you can see on your screen that how they have used this 3D printed parts, and they are using as an end use part for the rolling stock interiors and for the exteriors also. Even for the shop floor, for the tooling sector, for the rolling stock manufacturing aids, we can 3D print the jigs and fixtures, and we can do many more tooling components also. So we can the 3D printing can help to cut the lead time by 60 to 90% on the shop floor. We can customize the jigs and fixtures to improve its ergonomics and productivity. We can maintain a digital inventory, and we can eliminate the need of the physical storage. We can print on demand, 3D print injection molds for test runs for small quantity. So we can make the 3D printed injection molds also to test out your runs for small quantity solutions. This is one case study from the Siemens here for their mobility, from the Siemens mobility. So Siemens mobility requires to print low volume spare parts for interior and exterior use on the rolling stocks. With the help of the Stratasys 3D printing solutions, the FDM technology, they have been able to save their lead times by up to 95%. They have been able to optimize 3D printing ready to go parts. So this is one example here, retrofitting versus USB covers for the charging stations here, the charging portals there. So they have made the covers of those USB chargers, displays, and the digitalization devices. This is one more example here for the exterior stocks, also for the interior cockpit parts also. So this is the armrest for the driver's seat. The coating was done by RL 706 material, the texture, and this is the assembly for the housing bottom part. Uh, we can also do the 3D printed bumpers also. So this is the 3D printed bumper on your screen. You can see here that they have used it directly on the rolling stocks. For the streamlined supply chain, also they are doing the jigs and fixture. They are replacing their heavy metal fixtures by the nylon and carbon fiber ultimate material made lighter weight fixtures. This is an example from the Bombardier transportation. They have been able to utilize this technology to speed up their development process. So you can see the examples here: the door lock, which is printed in ASA material, air duct, lamp holder, external duct, character holder, mounting brackets, capacitor. So they have been able to do a lot of parts, interior or the exterior parts, large parts, small parts, and they have been able to replace their metal parts directly from the 3D printed parts. This is again one more success story by the Alstom here. So in North Africa, they have printed the drain plugs with the TPU material, which is thermoplastic urethane material, and instead of doing the tooling and prototyping, they have just made the new designs and they are using for the spare part services. So for the supply of their spare parts, they have been able to save 45 days for every stocks or for every component that they have to save it in the physical storage. So if we talk about the exterior parts, is how the what are the exterior parts that can be done for the in the where you require the low volume capacity also. So we can do the mirror covers, we can do the large covers, we can do the hand lamp support bracket and the cover. For the interior ones, we can do the HVAC covers, display cover, grab handles, armrest, spare parts. Uh, this is one more example for the trolley bus here. So in this trolley, head part was obsoleted, so this was not available with any vendors, or there was scarcity and there was no design also to the engineers also. So they have reverse engineered the parts, and they have been able to complete its manufacturing, and they were able to save the lead time by 12 months, from 12 months to few days only. There have been a significant cost saving, and the part was meeting the bus standard also for the bus fire regulation. This is one more example, like for a bus driver door for the low volume production of it, which has been printed within 60 hours. So there is no requirement of the injection molding tooling. This is a perfect solution where you require the low volume production, like tens or number of pieces or hundreds or number of pieces. And this part is about 800 millimeter part, and this Ultim 9085 material was meeting the bus standards, like for the fire bus regulation. So, thank you all. This has been, I hope that this has been a wonderful session for all of you. And we can utilize our Stratasys solutions here, our 3D printing solutions here for the rolling stock, for aerospace, for new e-mobility solutions. So this session has been done to give you an idea, to give you all an idea that how we can utilize this new technology, this industry 4.0 technology in the market, by improving our new product developments, by improving the designs, improving our ergonomics on the manufacturing floor. and how we can utilize it for upcoming future projects, upcoming future ideas for the automotive, or for the e-mobility solutions, or for automotive, for rolling stocks, railways, or even for the aerospace industry. Thank you, everyone, and we can take any question answers if you have any. Thank you.